an absolute value inequality now. We're going to use the tree method, which means we're going to solve two problems, much like we had to solve two problems for the equations. So, first step is decide, is it and or? And that's an important thing to actually know. So, in this case, we look, it's away from the absolute value. It's going to be an and statement, but if in case you forgot that, just put our little thing here. And last time we looked, negative 5 was less than 5. Since it's a true statement, we know it's an and. So, now that we've established that it's and, we're going to solve two problems. We're going to solve the original problem that they gave us, which is x minus 2 is less than 5. And we're also going to solve for its opposite, for the negative version of it. Now, you need to isolate the absolute value. So we're going to have to divide by a negative 1 or multiply by negative 1. So I'm going to multiply by negative 1, making that a plus. When I multiply by negative, I turn that around, and I have to multiply that by negative 1. So you're going to solve for the original, and you're going to solve for the opposite. Flip it around, and make it the opposite sign. So let's solve these problems. Let's add 2 to both sides here, and we're going to get that x is less than 7, and we're going to add 2 to this side, and we're going to get x is greater than negative 3. When it's an and statement and you have to graph it, it's actually a lot easier when it's written this way. We're going to put our larger value here. We're going to put our smaller value here. So 7's the bigger number. I'm going to put it here. And if you check it out, the 7 is getting eaten. And in this case, the 7 was getting eaten. So you have this done correctly. The smaller end is a negative 3. So now we're going to graph this. We're going to put on the smaller end an open circle, because it doesn't get to equal it, and we're going to put an open circle on the 7. And we're going to color everyone in between. And now we're set. So let's try a second one together where you'll do a little bit of it on your own. Let's try this out. We've got this situation. The absolute value is being eaten. And if you remember, that is an or. But in case you didn't, you just do what we said, and you check it out. Negative 5 is not actually greater than 5. Since it's not a true statement, it's not inclusive, so it's going to be or. So we're going to solve for this. X minus 2 is greater than or equal to 5. Or we're going to also solve for the opposite version of it. And again, when you isolate it by multiplying by negative, you're going to get x minus 2. This is going to flip. We're going to be solving for the opposite number. So we're also solving for this. So let's do those two problems. Hit pause, and we'll graph it together. Okay, you should have gotten that x is greater than 7 or x is less than or equal to negative 3. Or statements usually have the arrows going in opposite directions. So let's get these graphed. X is less than or equal to negative 3. Since it's equal to, we're going to color it in. And our arrow is going this way. Let's color in that direction. Don't forget your arrow. Now on the other end, we have got that x is greater than or equal to 7. So color in 7. Again, we start with the x, and it's pointing in this direction. So all the numbers that are bigger than 7 are located over here. Put your arrow. And that's what it should look like. So all that I want you to do, the first thing I'm going to check is I would like you to try this problem. The absolute value of 2x plus 3 is less than or equal to 7. Try that problem out, get it graphed, and bring it to school tomorrow. If you want to know how to solve these problems doing only one problem, watch the next video. Otherwise, just come in tomorrow. The last video is optional.